The 6.1 notes is your introduction to regular polygons. We're really interested in finding the area of these shapes in what we call section 10.4. But first we want to be able to figure out some angles. We define a polygon as a closed figure. More strict definitions of this will work for us. A regular polygon is equilateral as well as being equiangular. Really, these are not one and the same. To be a regular polygon, you must be both. You've got to be both equilateral and equiangular. All right. We define a convex polygon. There's a very complicated definition for our use. We just need to know that it needs to be kind of normal. I don't have a better word for it. I wish I did. A concave polygon is caved in. That's an easy way to relate that concept. It's worth your time to know these words: triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon, pentadecagon, and an n-gon, meaning that if we had a 31-sided shape, we would call it a 31-gon. As always, you can adjust the speed of the video as well as adjusting for subtitles. There are a few ways to get to the sum of the interior angles of a of a polygon. My preferred way I've shown in green is doing 180 minus the exterior angle and multiplying that by n. There's also this idea of taking n minus 2 and multiplying by 180. In that situation, the number of triangles times 180 is what you're trying to work with, and n is the number of sides. In our examples, we'll be asked to find the measure of the sum of the interior angles of a decagon. And since n equals 10, that means that if I drew a decagon, I could fit 8 triangles in there. Each of those triangles containing 180 degrees, and that would give me 1,440 degrees. If you'd like a further illustration of that concept, we can see that if we have one triangle, we'd only have one triangle. If we had n equal to 4, then we can fit 2 triangles in there. And it's 2 less than the number of sides. And when n equals 6, we'd have 4 triangles. And this pattern would continue. Since we have a quadrilateral here, these are going to add up to 360, and you would get that x equals 9. You might want to confirm that. To get one interior angle, you can do the number of triangles times 180 over the number of sides. I prefer a better way, which is to do 180 minus the exterior angle. The sum of the measure of an exterior angle of each polygon, of a convex polygon, is 360 degrees. And the measure of one exterior angle in a regular polygon is 360 over n. It's the sum 360 divided by the exterior angle, or the number of exterior angles. For example, 3, you would add up all these values to equal 360. So we're looking at all 5 exterior angles here. For example, 4, we're looking at getting n equal to 12, so we'll do 360 over n, 360 over 12, which is 30. 30 would be the exterior angle. We need the interior. We can calculate it very simply because the supplement of 30 is 150 degrees. Sometimes the problem can be asked in reverse order, meaning find the number of sides if I know the interior angle is 108. So if the interior angle is 108, then the exterior angle is 72. I know that the exterior angle equals 360 over n, and so that means that I've got 72 as the exterior angle. I can use the property of proportions to switch the A and D components. So n moves to the top left and 72 moves to the bottom right. And now n is 360 over 72, which is 5. Find the number of sides. This would be a pentagon. We'll pick up on the 10.4 notes in just a moment.